We believe our universe is real, that the ground beneath our feet is solid, and the stars above are fixed. But what if it's all a grand illusion? What if reality is far stranger, more fragile, and more complex than we can possibly imagine? Some of our most brilliant physical theories, when pushed to their absolute limits, suggest exactly that. These aren't just philosophical musings. They are the startling possibilities that emerge from the mathematics that governs our cosmos. First, the holographic principle. It suggests that your life in 3 dimensions, every sight, sound, and feeling, might be an illusion. This theory, born from the physics of black holes, proposes that our entire 3D universe is a complex projection of information stored on a distant, 2-dimensional surface that surrounds us, like a cosmic hard drive. Everything that has ever happened and ever will happen is just the unfolding of a script written on the edge of the cosmos. Your sense of depth, your freedom of choice, all an elaborate hologram. But what if the illusion is even deeper? The simulation hypothesis argues that our entire universe is a hyper-advanced computer program. The logic is simple. If any civilization ever becomes advanced enough to simulate a universe, then simulated universes will inevitably outnumber the one base reality. Statistically, it becomes almost certain that we are living in one of the simulations. The laws of physics are just lines of code. Your consciousness is part of the program. And the most unsettling part, a simulation can be turned off. Perhaps the most terrifying theory is that our universe exists in a fragile, temporary state. It's called false vacuum decay. Think of it like a drop of water perched on a mountaintop, stable for now, but not in its lowest energy state. At any moment, a random quantum event could nudge a patch of our universe into its true, more stable state. If this happened, a bubble of true vacuum would expand at the speed of light, instantly rewriting the laws of physics and erasing everything it touched. We would never see it coming. In a flash, everything would simply cease to be. But for every end, there is a beginning. Black hole cosmology offers a potential answer to the question, what came before the Big Bang? The math describing the infinitely dense singularity of a black hole is remarkably similar to the math of our own universe's origin. This theory suggests that every time a black hole forms, the matter it crushes doesn't just disappear, it bounces and expands into a new, separate spacetime, a child universe. Our entire cosmos could be the offspring of a black hole from a parent universe, creating an endless, cosmic family tree. Holograms, simulations, fragile realities, and cosmic ancestry. These ideas stretch the limits of our imagination, reminding us that the solid world we know may be just one page in a much grander and much stranger story. From the grandest ocean to the humblest cell, one substance connects all life as we know it: water. It is the universal solvent, the stage on which the chemical dance of life is performed. Its unique ability to dissolve more substances than any other liquid allows it to transport the vital nutrients and minerals that every living organism needs to survive. It builds our proteins, copies our DNA, and moderates our planet's climate. For life on Earth, water isn't just important, it is the matrix of existence. So how did this dance begin? The leading theory takes us back 4 billion years to a primordial soup. In warm, shallow ponds, or perhaps in the fiery, nutrient-rich chasms of deep-sea hydrothermal vents, water was the cradle. It mixed a cocktail of simple chemicals, energized by lightning or geothermal heat. Over millions of years, these chemicals linked together, forming the first complex molecules, the first self-replicating strands of RNA, and eventually, the first simple cells. In the turbulent, life-giving waters of a young Earth, the first spark of biology was ignited. But is our way the only way? We are carbon-based life forms, utterly dependent on liquid water. But the universe is vast and endlessly creative. Scientists now seriously consider the possibility of alternative biochemistry. Could life exist on a world like Titan, where temperatures are so low that water is hard as rock, but liquid methane flows in rivers and lakes? Could this freezing liquid methane take the place of water, supporting a slow, strange form of silicon-based life? The honest answer is, we don't know. The universe isn't required to play by our rules. And yet, in our search for life beyond Earth, we start with what we know. We follow the water. In our own solar system, the clues are tantalizing. Jupiter's moon Europa and Saturn's moon Enceladus are hidden water worlds believed to harbor vast, salty oceans beneath their thick shells of ice. Enceladus even erupts geysers of this water into space, proving a liquid sea exists below. And further afield, the discoveries are staggering. We found water vapor in the atmospheres of giant exoplanets and on super-Earths like K2-18b, a world that could be a Hycean planet, a hot, water-covered world with a hydrogen-rich atmosphere. Each discovery brings us closer to answering the ultimate question. While life might take forms we can't yet imagine, the shimmering, life-giving signature of water remains our brightest beacon in the cosmic dark, our most promising guide in the search for a second Genesis.